In this video, we will see dry run of the code. Now let's do a quick dry run of this code. I am finding is it cyclic or not. Okay. So I have V as in vertices. Basically, I have 3 vertices. Okay, sorry, not 3. Total is 4. So we have 4 vertices. Okay, 1, 2, 3, 4. Okay, what I will do, I will create a visited array first. I will create a path visited array and all of them I will fill with false. So I will fill with false. Okay. So this is done. This is done. Created a visited array. Okay. Created a path visited array. And remember, we have given with the adjacency list, right? So this is the adjacency list. So this is given. Okay. This is also given. Adjacency list. This is also given. From here, I am creating it. Okay, this is my basically, you can say dry run. Okay. So now what I will do, I will start from 0 and I will go till V. So I will start from 0, 1 and 2 and 3. Till this I will go. Okay. I will check if it is not visited. If 0 is not visited, yes, 0 is not visited. 0, 1, 2, 3. 0, 1, 2, 3. So 0 is not visited. What I will do, I will call my DFS function. So I will call the DFS function, that is DFS of 0. So when I call this DFS of 0, okay, let's see my DFS function now. So when I'm calling this DFS function, okay, maybe I have written it's 2 times. Okay, it should not be here. Let me copy this. This. So we are talking about DFS. Now when I'm visiting DFS, I will visit that node and will mark this 2 and I will visit path or I will mark that is also true. So I will visit this node and I will mark this as true. Okay, red pen. I will mark this as true and I will mark this as basically path and visited. Now I will check neighbor of my adjacency node. Okay, adjacent node. So what was my node? My node was 0. My node was 0. Basically, what is the neighbor of it? That is 1. Right? You can see in the adjacency, I'm getting 1. So I will check. I have not visited 1. Yes, you have not visited. So I will again call the DFS. So again, I will call the DFS. From 0, I will call that 1. When I'm calling that 1, okay, I will make both the true. So I will make these two as true. Okay. So I will make this is also true. And I will make this is also true. I will check neighbor of my adjacent node. I will check neighbor of 1 then. What is the neighbor of 1? That is 2. So I will check for 2. Okay. So again, I will check neighbor of 2 and I will check if it is not visited. So yes, 2 is not visited here. So what I will do, I will call the DFS, right? I will call the DFS. So what I will do, I will call the DFS. Let's call it. So I will call the DFS of 2. When I am calling, right, I will execute DFS. I will make visited node true, path node true. So I will make this true and this true. Okay. Now again, what I will do, I will check the neighbor of again here, neighbor of adjacency node, neighbor of 2. What is the neighbor of 2? That is 3. So I will check 3. Okay. I will check 3. And how I will check? I am basically checking of adjacency node. I am checking 3 and I will check if I have not visited 3. Yes, you have not visited 3. So again one DFS function call. So again one DFS function call, that is DFS of 3. So I will call DFS of 3. Now I will make visit when I'm calling DFS of 3, I will make visited node and path node equals to true. So I will make this node equals to true and path node equals to true. Okay. Now when I have made this, I will check neighbor of my adjacency node, neighbor of 3. Neighbor of 3 is 1. So I will check. Okay, now it's important. Now I will check 1. Is 1 is visited? Yes, that's true. Okay. So if not visited, it's like not visited. So this is visited. So I will come to else condition and I will check what is the path of my neighbor. Path of my neighbor, that is path of 1. That is also true. Okay. So yes, right. When both the conditions are true, this is also visited. This path is also visited. Both the conditions are true. I will simply return true. I will simply return true. Okay. When I will return true, so basically DFS 3, right? From DFS 3, I got the adjacency node and I have checked 3. So this is basically returning true. This will basically return true. And this will basically return true. and how now I am getting true here. Now when I will get true in this condition, I will return true, and basically the output will be true. Yes, that it has a cycle. Okay, has a cycle. Okay, so yes, basically this is we will execute, right? We will get the true. We will simply execute. Remember, when there is not a cycle, when this function will basically here dfs3 if complete, I will return. I will make path node equals to false. So I will make this one as false, false. But here we got the true, so we will return true. So that's all about dry run of our how to detect a cycle. I hope you are clear with this, how we can detect a cycle in a directed graph. Okay. There is one problem that we can solve this problem by using BFS also, BFS technique. For this, you need to understand about topological sort. So we'll check if we cover the topological sort, then we will solve it by using BFS also. Okay. So till then, this is the solution of it. Okay. We'll see more problem on graphs. Okay. Till then, bye bye. Thank you and see you in the next video.